Hi class, so for this video, I want to introduce the application of system of linear equation. So when you read the problems and you realize that we have to call two variables, that means you have to use system of linear equations. Therefore, you need two equations, not just one equations. So any application problems, the first thing you need to do is to name the unknown. Okay, so after you read the problems, the Washington family and the Powell family, they're talking about sprinklers. I just want to point out something. So you can see right here, we have the rate. Okay, so this is the rate. Now, this is the number of hours. And they're asking you for the number of hours for each family. So you should know that the rate is different from the number of hours. So one is liters, the other one is hours. The rate is actually liters per hour. But anyway, I just want to point that out. So when you do any problems, you have to be careful with the units. So you know that for this, for X is gonna be, I'm gonna put the hours of the Washington family. And then Y is going to be the hours of the Powell family. All right. So what's the rate of the Washington? The rate of the Washington family's sprinklers was 35 liter per hour. And for Powell is 25 liter per hour. All right, so we don't know the numbers of hours. We don't know the number of hours for the Washington family, so I'm going to call X, just like how we name it. And then for the Powell, it's going to be Y. So for the total water's output, what do? We take the rate, we multiply by the number of hours. So what I have right here is 35 times X. And then the bottom, I have 25 times Y. All right. So one piece of information that I give you is the total water output of 1275 liters. So that should give you one equation right there. So the equation is 35X plus 25Y equals 1275. You see what I have is liters plus liters equals liters. All right. So I need to come up with a second equation. And the second equation, they give you the combined total of hours. So you can take X plus Y equals the number of hours. So like I said, liters plus liters equals liters. Hours plus hours equals hours. So for this problem right here, I would use substitution. So I'm just gonna solve for X here. You can solve for Y if you want. So it's 45 minus Y. All right, now we plug it in. So what I have is 35. Instead of X, we have 45 minus Y plus 25Y equals 1275. From here, you should be able to calculate and isolate Y. So I combine like terms. So Y is 30 hours. This is the Powell family. Okay. Now you can go back to the equation that we saw previously, this one right here. That one would be the easiest equation we can use to solve for x. So x is 45 minus 30, which is 15 hours. And that is the Washington family. All right, moving on to the next application problem. Every time I have chemical or any like anti-freeze or the mixture problems, I always call that the Walter White problems. So instead of making a table, I always draw. So let's say the first brand is 45% pure anti-freeze. So this is my beaker. So I'm gonna label it 45%. And then we adding the second one, 70% pure anti-freeze. And then we want to mix them up. And this one is 65% pure anti-freeze. Now, what do we have inside of the beakers? So we know nothing about the first one. So I have X here, right? We know nothing about, we don't know the volumes of the second brand. So I'm just gonna put Y. We do know the total, so that's 170. You see right there, I have the first equation, X plus Y equals 170. Now for the second one, you see the percent. So in order to figure out the volumes, I have to multiply the percent. So we have 0.45x plus 0.70y equals 0.65 times 170. And once again, you can solve for the first equation and use substitution. So once again, I'm going to use x, 170 minus y. All right, and then we plug it in. 170 minus y plus 0.70y (1110.5). All right, and from there, we just calculate. Hopefully I don't make any mistake, but just in case we make mistake, the number is gonna come out super weird. So we can tell if we make mistake. Okay, so y is 136. Let me see the units, gallons. Okay, and y is the second brand, which is a 70% anti-pure. Like I said, if you make mistake, let's say if you calculate it and then the answer come out to be a negative number, that doesn't make sense, right? So now from here, we have 170 minus y, which is 136. So the first brand is 34 gallons. Okay. All right, moving on to the next application. of system of linear equation. So every time you see a problem with miles going upstream, going downstream, you see rate, you know that that's the motion problem. So it's gonna be D equals to RT. D stands for distance, R is rate, and T is time. So usually for these types of problems, it helps if you make table, right? So we have two things we need to figure it out, which is the rate of the boat and the rate in still water and the rate of the current. So I'm gonna cause X and Y again, or you can cause B and C. So B is rate of the boat in still water, and C is the rate of the current. Okay. So if we go upstream, we go against the current. So I have to take B minus C for this one. If we go downstream, that means we go with the current. So it's going to be B plus C. Now the time, it takes 5 hours to travel 200 miles going upstream. So the time is 5 here. Return is take 4 hours. So it's 4 there. And then we have 200. Okay. Now the return trip. So it's going to be the exact same distance, right? So 200 here. All right. And like I said, we're going to get R times T equals to D. So we take rate times time equals D. So you multiply these two, you're going to get this one, right? All right, I'm just going to put the number in front. So I'm going to put 5, B minus C equals 200. And then 4 times B plus C equals 200. You can definitely distribute the 5 and the 4 and then proceed the problem with elimination. In this case, I know that 5 is divisible by 200 and 4 is divisible by 200. So I'm just going to divide first. So I divide by 5, I divide by 5, divide by 4, divide by 4. So my new equation is going to be B minus C equals to 40. And then I have B plus C equals 50. All right, and then we can use elimination to eliminate one variable, which is C in this case. So I have 2B equals 90. All right, so B is 90 divided by 2, so it's 45. So what we have is 45 miles per hour. That's going to be the rate of the boat, right? And then I can just pick B minus C equals 40 or B plus C equals 50. So B plus C equals 50 and B is 45. So we know C is going to be 5 miles per hour. We got it.